Hello students, in this video we are going to talk about some of the properties of halides of group 15 elements and also about the preparation and properties of the element nitrogen. Now what are halides? Compounds of elements with halogens are known as halides, and group 15 elements are known to form two series of halides known as trihalides and pentahalides. The general formula being EX3 and EX5, where E represents the group 15 elements and X stands for the halogens. Now, among group 15 elements, nitrogen does not form any pentahalide. This is because it does not have any d orbital in its valence shell, and hence it cannot expand its covalency beyond 4. Now, the pentahalides are found to be more covalent in character than the trihalides of group 15 elements. This can be explained by considering the Fajan's rule, which says that the higher is the positive oxidation state of the central atom, the greater is its polarizing power, and hence more is the covalent character of that compound. So in PCl5, since phosphorus is having an oxidation state of +5, and in PCl3 phosphorus is having an oxidation state of +3. So +5 being greater than +3, the polarizing power in +5 state is greater, and hence the covalent character also is greater for PCl5 as compared to PCl3. Now when we study the properties of the trihalides, we see that except for bismuth trifluoride, all other trihalides of group 15 elements are predominantly covalent in character. Now bismuth trifluoride is having more percent ionic character, and that could be explained by considering the difference in their electronegativity. Bismuth is an electropositive element, whereas fluorine is the most electronegative element. So the difference in electronegativity between these two elements being large, the percentage ionic character of the compound is higher. Now all the trihalides of this group of elements except those of nitrogen are found to be stable compounds. But in case of nitrogen, except for nitrogen trifluoride, all other trihalides are less stable. And this can be explained by the bond strength of the NF single bond, which is higher due to the comparable size of nitrogen and fluorine, and hence the bond formed by overlapping of the orbitals of nitrogen and fluorine is a stronger bond, as the overlapping is more effective. If we compare the properties of the nitrogen trichloride and nitrogen trifluoride, then we find that NCl3 undergoes hydrolysis, whereas NF3 does not. That is, NCl3 reacts with water, forming ammonia and hypochlorous acid. This can be explained by considering the low bond strength of the NCl single bond, and also by considering that chlorine has vacant d orbitals in its valence shell, whereas fluorine does not have d orbitals, and also the NF bond is stronger than the NCl bond. Now the first member of this group is nitrogen. When we see its methods of preparation, we find that it can be prepared both commercially on a large scale as well as in the laboratory. On a commercial scale, it is obtained by fractional distillation of liquid air. Liquid air mainly consists of liquid dinitrogen and liquid dioxygen. Boiling point of liquid dinitrogen being lower, that is around 77.2 Kelvin, it distills off first during the fractional distillation process, leaving behind liquid dioxygen, which has a slightly higher boiling point of 90 Kelvin. In the laboratory, we can obtain nitrogen gas by reacting aqueous ammonium chloride with aqueous sodium nitrite. Apart from nitrogen gas, sodium chloride and water are the other side products obtained during the reaction. Nitrogen can also be obtained by thermal decomposition of some of the nitrogen containing compounds. For example, ammonium dichromate on thermal decomposition produces nitrogen gas, water and chromium trioxide. Similarly, the azides like sodium or barium azide, on strong heating at around 573 Kelvin temperature, decompose, producing pure nitrogen gas and the other element. For example, if sodium azide is heated, it produces sodium metal and nitrogen. When we see the properties of nitrogen, then we find that it is a colorless, odorless and tasteless non-toxic gas existing in the form of two stable isotopes having atomic masses 14 and 15. Now, nitrogen is inert at room temperature, that is non-reactive in nature, and this could be due to its very high bond dissociation enthalpy due to the presence of triple covalent bond which binds the two nitrogen atoms together in the diatomic molecule. But at higher temperatures, it can react with metals as well as non-metals. For example, on heating, it reacts with lithium, which is an alkali metal, as well as with alkaline earth metals like magnesium, calcium, etc., to form the respective nitrides. It can also react with hydrogen when heated to a temperature of about 773 Kelvin in the presence of catalyst and at higher pressures, forming ammonia gas. It can also react with oxygen gas at very high temperatures, say about 2000 Kelvin, to form nitric oxide gas. Some of the important uses of nitrogen are that it is used for manufacture of nitrogen containing compounds, for example ammonia and several other chemicals. Then it can also be used to create an inert atmosphere, and liquid dinitrogen is often used as a refrigerant to preserve several biological materials as well as certain food items.